Hello everyone, you are welcome back to my class. In our previous class, while we were solving question 2 on inclined plane, I made a promise that I was going to show you why we said that angle 30 degree here is equal to 30 degree here. Is that correct? So let's get to that today. So without much ado, so let's draw our inclined plane. So here is our inclined plane. So here's the horizontal, and then here is the inclined plane, right? And as usual, here become the load. Here's our load, right? And the weight of the object will act downward, right? The weight of the object will act downward. So the weight is acting downward. So the weight is W. Is that correct? So the weight is W. And we said the component of this weight acting along the inclined plane is this, and we call it WX. Is that correct? And we said that the normal reaction is always acting perpendicular to the plane, right? So here become our normal reaction, which is always perpendicular to the plane. So normal reaction is R. I hope this is taken. Now, and the component of the weight perpendicular to the plane, right? Component of the weight perpendicular to the plane, yeah, which is always equal to the normal reaction. Sorry, it's always equal to the normal reaction. So here's the component of the weight. We call it WY. So we say that if this place is the angle to the horizontal, the angle inclined to the horizontal is theta. We said this place is also theta. But today we want to prove how it is like that. So we all agree that here is a right angle triangle. Let's call it A. Let's call it ABC, triangle ABC. Is that correct? So if that is correct, it shows that if here is theta and the whole angle here is 90 degree, that is a right angle triangle. Therefore, this place here, the angle here should be 90 minus theta. I hope I'm correct, right? Should be 90 minus theta. So the angle here we don't know. Let's call it X. As usual, by the time we place this our inclined plane, you bring it down just as if you replicate it. You bring it down to form a right angle triangle here. By the time we do that, by the time we bring it here, so that here will still be our WX, right? And here is our WY, right? And here, this one become our W, the hypotenuse, and automatically we have a right angle triangle here. So we don't know this angle X, which we are going to use like what we did here. We used to calculate the force along the inclined plane and what have you. So in order for us to know this angle here, we now consider the whole of this. If you look at if you look at from here to here, look at it, take note of this. From here to here, it forms a right angle. Is that correct? So it's supposed to be here. It forms a right angle. So if it forms a right angle, it shows that from this to this is what? 90 degree. Angle 90 degree. Is that correct? So the sum of the angle is what? 90 degree. In that case, it shows that 90 degree minus theta plus x is equal to what? 90 degrees, sum of angle in a right angle, right? Good. So if that is the case, it shows that if I bring this one to this side, I have 90 minus 90, right, minus theta, right, is equal to minus x. And this positive 90 will take away a negative 90. I'll be left with negative theta equal to negative x, which implies that x is equal to theta. As simple as that. So that is why, in any case, we are given the angle incline, so automatically we just use it here as the angle we are going to use to calculate our force along the incline and force perpendicular to the incline plane. Is that understood? So having established that, we now, from here, can also now put here to be theta. We have already established theta. So this theta is facing this side. So we can have SOHCAHTOA, that is opposite of a hypotenuse. So I'm going to have sine theta is equal to opposite, which is WX, all over hypotenuse, which is what? W. This implies that WX is equal to, when you cross multiply, I have W sine what? Sine theta. Is that correct? So if you write weight in terms of, if you write the weight in terms of mass, that is mass times acceleration due to gravity, this shows that the component of W, the weight, along the component of weight along it shows that the component of the weight along the inclined plane is equal to mg sine theta. I hope this is understood. So in that case, when you come to the component along the inclined plane, it is equal to mg sine theta. Is that understood? Also, if you look at the component perpendicular to the inclined plane, which is this one, so we are going to have adjacent over hypotenuse. Is that correct? So that is going to be cos. Have cos theta is equal to adjacent, which is wy, all over hypotenuse, which is w. This implies that wy will be equal to w cos what? Cos theta. So by so doing, I have my wy equal to w in terms of mass, that will be mass times acceleration due to gravity, then cos what? Theta. So that shows that this component of the weight perpendicular to the inclined plane is equal to mg cos what? Cos theta. Is that understood? So in a simple form, anytime you have this kind of question, anytime you have this type of question, just draw this inclined plane, as simple as this. Draw the inclined plane like this. Put the weight here. A lot of questions that can come from here, but if you know this basic, if you put it here, just draw this as the weight acting downward. You can write W equal to mg. Good. Then draw this perpendicular, which is the normal reaction. Am I communicating? Here to be normal reaction R, and make this to be mg cos theta, and put here to be theta, as this place is also what? Theta. As simple as that. So anytime you have questions that lead to inclined plane, so you now come to this place that will give us the component of the weight along the inclined plane like this. Then you call this mg sine theta. Is that correct? So depend on the question given to you. So if you want to go further, if the body is sliding in this direction, right, if the body is moving in this direction, therefore the frictional force will be opposite. will be opposite, right? The frictional force will be opposite. So we have FR. Is that understood? As simple as this. So from here, we can now derive another formula. Remember that frictional force is equal to mu R, which implies that mu is equal to F all over normal reaction. Is that correct? Okay. So just before the body starts moving, FR, the frictional force is equal to, limiting frictional force is equal to mg sine theta, and the normal reaction R is equal to mg cos theta. Is that correct? So from here, I have my mu equal to FR now become mg sine theta all over mg cos theta. So that mg we cancel mg, we'll be left with what? Sine theta all over cos theta. Is that understood? So this implies that what? That mu is equal to sine theta all over cos theta, which is equivalent to what? Tan theta. So apart from this formula, so we also have this formula that mu is equal to tan theta, as simple as this from this diagram. I hope this is understood. So anytime you have question, so depending on how we are going to be treating many other questions that relate to this, depending on how the question is, just draw your inclined plane, label them like this, and start working your workout. Is that understood? So that is about this question, and I think we are going to stop here for today and continue from here in our next class. Thank you for your time. See you in the next class.